Two dice are rolled, one after the other. Construct a sample space and determine the probability that the sum of the dots on the dice total given. So what I have here, this is the sample space, the entire sample space. So here we have, I don't care if you want to call this the first die, and this is the second die. And these are all the pairings. The first case says, what's the probability that the sum on the dots total 6? Okay, so we get 6 in which cases? 6 here, 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 and here out of 36. 6 times 6 is 36 possible. So the probability of 6 is 6 cases out of, I should say 5 cases out of 36. That was 1, 2, 3, 4, 5. 5 out of 36. I'm going to scroll this up so I have the whole chart on the board now for the next several problems. B says, what's the probability of a 6 if the first number is a 1? Okay, so if we know the first number is a 1, what's the probability of getting a 6? Well, there's only one case that we get a 6 knowing the first number is a 1. Equals the number of the ones that have a sum of 6 and the first number being 1 over the number of things that it's first number being 1. There's one case in this whole row that you get a 6. These are all cases where the first number is a 1. And there are 6 cases altogether. So this is 1 over 6. How about the probability you get a sum of 6 of the first die is a 3. Probability of a 6 given, I should say sum of 6 given a 3. That's the number of the ways you can get the sum of 6 and a 3 at the same as the first number over the number of ways things you get with a 3. So here we go. First thing's a 3. Here's the one that has the sum being a 6 out of 6 options. So 1 out of 6 again. Event D says an even number. What's the probability of getting an even number if the second die is a 2? Probability of even given a 2 for the first thing. That's the number of ways you can get an even number and have the first one be a 2 over the number of ways you can have 2's. It's the first number. Okay, so here 2 is the first number. We have 1, 2, 3 evens in that row out of 6 altogether, or 1/2. I need to scroll up a little bit for the next 2. Okay, E, a number greater than 7 if the second die is a 5. Well, I think we can still use this row. Probability of being greater than 7 given 5 for the second number. Second die. Okay. Well, here's where a die is 5. How many of these are more than 7? That's 7, so we have 1, 2, 3, 4 more than 7. That's number of the sum being greater than 7 and second die is 5. So we found that occurred 1, 2, 3, 4 times out of the number of cases where the second die is 5. That's 6, so 2/3. And the last one, what's the probability of getting a 7 or 11 if the first number is a die? Probability of 7 or 11 given first die is 5. That's the probability, or the number of ways you can get a 7 or 11, and first die is 5 over the number of ways you can have the first die be a 5. Okay, so 7 or 11. That's a 6. Here's a 7. 8, 9, 10. There's an 11. So there are two cases where we get a 7 or 11 divided by the first die being a 5. There are 6 cases. So 1/3.